Okay, this video is to explore the formula for area of an equilateral triangle and how I would find the area of an equilateral triangle. So we have a formula for area of a triangle, either 1/2 base times height or base times height divided by 2. And we can use that just like we do for any triangle. So this is a special triangle, but there's no reason that we can't use our traditional formula and say, okay, assuming that I had the height there and I have the base being the thing that it's sitting on, I'll call that the base. I could just plug those in, okay? But in the case of an equilateral triangle, there's some other things that we know that do allow us to simplify this formula. So just as an alternative and a way of showing you how we derive formulas, really, and simplify things, let's recall that in an equilateral triangle, all three side lengths are the same. So instead of just using B for base, I'm going to use S, and any one of those would be my side length. So I can replace my base with my side length. And then we can figure out what the height would be in terms of the side length. So if we take one of these triangles, recalling again that an equilateral triangle is also equiangular, leaving us with 60 degrees for all the angles, and therefore a 30, 60, 90 triangle, or two 30, 60, 90 triangles, then I can either start with my hypotenuse that has a side length of, that I'm calling S, and get that my short leg across from the 30 down here is going to be 1/2 S. Or we could also see that by looking across the bottom and seeing that we have S for the entire base, therefore each one of those is going to be 1/2 S. And then the long leg is going to be 1/2 S times whatever my short leg is times radical 3. So 1/2 S times radical 3. And that allows me to replace, that's equal to my height with 1/2 S radical 3. And that's all being multiplied together. So if we simplify that, then I'm just going to simply take the 1/2 and 1/2, since those are numbers, multiply those, get 1/4. And then I'm noticing that I have an S and an S, and that's really just S squared. And then I also have a radical 3. 1/4 times radical 3 gives me a radical 3 over 4 is probably the easiest way to write it. So either that or radical 3 S squared over 4. A lot of times we'll switch it just to be mathematically sort of precise, and put the radical at the end just so we don't get confused with, like, is the S squared inside the radical or not. So any of those would be a version of a simplified formula for when we have an equilateral triangle. And the advantage is, if I am dealing with a situation where I need to find the area of a lot of equilateral triangles, I would only have to know the side length, which is generally what we know about an equilateral triangle, and we could just plug it in and just hammer out some numbers and figure out a whole bunch of areas. Okay, if I was going to try to program something to give me a bunch of areas, this would be super helpful because all I'd have to input is the side, and when you have to figure out the height, it would output a bunch of areas. Okay, if my goal is just to find the area of one equilateral triangle, then I don't know, you still have to go through the work to derive the formula to get the height. So it might be just as simple to do it with the number in there for the base. If the base was 10, then we would have figured out that this would be 5, and this would be 5 radical 3, going through the same thinking with this 30, 60, 90. And then we could just throw it in here, no big deal. Okay, but there are times where we want to be able to derive a formula, so I wanted you to see how this works, and it would be helpful when we're working backwards if all we know is the area and we want to find the side length. Now this is going to be super helpful.